In the previous lesson, we drew trend lines to model scatter plots, and what we're going to learn how to do now is to describe these trend lines using an equation. And we've already talked earlier about what that equation is, and it's a very familiar equation to us, and it's slope-intercept form. And slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. And this equation is called a linear model. And the linear model allows us to do a couple of things. One of the things that we can do is describe relationships between our two variables. And the other thing that we can do is make predictions. So a trend line represents the general pattern of the data, but because that line is linear, we can describe it using an equation. And that's what we're going to learn how to do here is write an equation to describe the trend line. So in order to write an equation, there are a couple of things that we need to do. And the first of those things is that we need to learn how to find the slope of a trend line. And this is also something that we have learned how to do previously, write an equation for the slope. And the equation can be written in a couple of different ways. One of the ways you can see here is the change in y over the change in x, and that triangle symbol there is the Greek letter delta, and it means change. So this is literally read as the change in y over the change in x. And the way we calculate that is by taking two coordinate pairs and we subtract the y coordinates and subtract the x coordinates to find out what the change is. And then we just divide those two differences. So the slope represents the rate of change between the variables, and slope tells us how much y changes when x increases by 1. So let's take a couple of coordinates to use as an example. And let's take the coordinates 265 and 685. And as usual, we're going to use the context of our students who are studying and the score that they get on a test. So let's assume this first coordinate pair, 265, is a student who studies for 2 hours and scores a 65 on their exam. And the second ordered pair is a student who studies for 6 hours and makes an 85. So our x coordinates here are 2 and 6, and our y coordinates are 65 and 85. So when we use our slope formula of subtracting the x's and subtracting the y's, we get 85 minus 65 on top for our difference of y's, and 6 minus 2 on bottom for our difference of x's. So 85 minus 65 is 20, and 6 minus 2, of course, is 4. And when we do 20 divided by 4, we get 5. So our rate of change, or our slope, between these 2 points is 5. In the context of our students who are studying for a test, what this means is that we expect their test scores to increase by about 5 points for every hour that they study. So that's one of the things that we need to find in order to write our linear equation, the slope. The other thing is the y-intercept. And the y-intercept is the spot where the line crosses the y-axis. And this is also the value of y when x equals 0. So here's our scatter plot of the data we've been working with of the hours studied and the test scores. And this is a familiar set of data to us, but we're going to add one more point on here. We are going to add a spot where x equals 0. Now what that means is a student who studies for 0 hours. And let's assume that a student who doesn't study at all makes a score of 55. And so we're going to go ahead and add their point on right there. So this new point that we added, 0.55, this represents a student who studies for 0 hours, and we would predict that they would get a score of 55. And that is our y-intercept in this case. And it's the y-intercept because that point is on the y-axis. So now we know the two pieces of information that we need. We have the slope, which we just calculated as 5, and now we have the y-intercept, which is 55. Once we have those two pieces of information, we can write our trend line. So our equation was y equals mx plus b, and all we have to do is replace the m with the slope and replace the b with the y-intercept. So instead of y equals mx plus b, we're going to have y equals 5x plus 55. What does this mean? The 5 means that we expect a test score increase of about 5 points for every hour studied, and the 55 means that we expect someone who does not study at all to get a score of about 55. So what were the steps that we went through in order to write this equation? Well, the first thing that we did was we found the slope. We had those 2 points and we used the slope formula to find the slope. Then we identified the y-intercept from our scatter plot. That was the spot where x equals 0. And then once we had those two numbers, we substituted them into our slope-intercept equation, y equals mx plus b, and that gave us our final equation. So once we have the equation, we can do something really valuable with it, which is that we can use it to make predictions. So let's take our equation that we just came up with, y equals 5x plus 55, and let's ask ourselves a question. What if we had a student who studied longer than anybody else that we have data for? What if we had a student who studied for 6 hours? So since our independent variable, or our x variable, was 6, that means we're going to take our equation and substitute 6 for our value of x. So we're going to take our equation of y equals 5x plus 55, but we're going to substitute our value of x with 6. So it'll be 5 times 6 plus 55. And now it's just a simple arithmetic problem. 5 times 6 is going to give us 30, and 30 plus 55 is 85. This tells us that we predict a student who studies for 6 hours would have a score of 85. So the equation of this trend line can be used to make predictions and describe the relationship between variables. So what have we learned? We've learned that trend lines can be written as linear equations. We've learned that the form of those equations is y equals mx plus b, where m is the slope, also known as the rate of change, and b is the y-intercept, which is usually our starting value. And finally, we've learned that these equations can be used to model relationships and to make predictions.